Welcome everyone. This is another review of relations and linear functions, but this time it's going to be specific to the assessment that you're going to have coming up very shortly on sections 2.1, 2.3, and 2.4 in the Pearson Algebra 2 book. So let's get started. Okay, if you remember, or if you were given a list of 8 things, this is what you need to be able to do, we're going to go through each one of those 8 things and give a couple of examples. You have a review sheet also that has other questions on it for each one of these sections, so if you want to kind of work along with that, you can, or use this as a reference to help you excuse me, with your review. So the first thing we want to do is find the domain and range of a relation and then determine if it is a function. So let's take a look at, first of all, a relation. What's a relation? Well, it's a set of ordered pairs. Any set of ordered pairs x and y. And so I'm going to give you an example here. We have the set of 1, 3, negative 2, 6, 4, 1, and 1, negative 10. Now, is this a function? Well, no, it isn't, because you can see the domain repeats. 1 maps to 3, and 1 also maps to negative 10. And in order for it to be a function, each element in the domain can have at most one element in the range. So this is not a function, but it is still a relation. So let's take a look at, we still can name the domain, and the domain would be the x terms, and we generally put them in order. You don't really have to, but we generally put them in order, and if one repeats, we only name it one time. So we have minus 2, 1, and 4 for our domain. And then our range, which is our y values, is going to be 1, 3, 6, and 10. All right, so let's go on to, let's do one with a graph. And I have a circle on this graph. And I want to know, is it a function? Well, it's not a function, and you can tell that because it does not pass the vertical line test. And but I still, once again, even though it's not a function, I can still find its domain and range. In order to find the domain, I want to look at the graph and I want to find out what's my smallest x value and my largest x value. And you can see this is not centered at 0, so if I kind of show you where the center is, you can see that the smallest x range is, or smallest x value is there at negative 2, and the largest is at positive 3. And for the y's, which would be the range, the smallest is negative 1 and the largest is 4. So it's going to be negative 1 is less than or equal to y is less than 4 or equal to 4. All right, let's go on to the next one. Evaluate a function given a value in the domain. Now that's a fancy way of saying I'm going to give you the value of x and you plug it in and find the value of y, or f of x. Okay, so remember domain is x. So I'm going to give you 2 functions written in function notation. F of x is x squared minus 1, and that's not a linear function, but we're just going to use it to plug numbers into. And g of x is 3x plus 6. So I want to find g of 9 and f of negative 2. So this is my g function, so I have to plug that negative 9 into my g function. So g of negative 9, 3 times negative 9 plus 6, which is negative 27 plus 6, which is negative 21. So I would say g of negative 9 is equal to negative 21. And if you want to write that as an ordered pair, it would be negative 9, negative 21. The other one is the f function. So I would say f of negative 2 equals negative 2 in parentheses squared. Now, why did I put it in parentheses? Because I'm squaring the x, and the x is equal to negative 2. So I'm doing negative 2 times negative 2. I'm not doing negative 2x. There's a difference. And so in order to be accurate, we have to keep that in parentheses. And of course, then minus 1. So this is 4 minus 1, or 3. So f of minus 2 is equal to 3, or negative 2, 3 is our ordered pair. Okay, the next one is find the slope of a line given 2 points on the line. And you've been doing this since the very beginning of Algebra 1. So if I have 2 points, 4, negative 2, and negative 1, negative 6, first of all, I want to reiterate that slope is rate of change. Rate of change, how fast things are changing, how fast that line is moving up or down. And we determine it by saying delta y over delta x. Now this is just a fancy way of saying the change in the y terms over the change in the x terms. And when you talk about change, you talk about subtracting. If you go to McDonald's and you have a $10 bill and your order costs you $7, your change is 10 minus 7. Think of it that way. So that's why we have to subtract. And so we'll have -6, -2 over -1, -4, which is -6 plus 2 over -5, or -4 over -5, and a negative divided by a negative is a positive. Now I know I'm going through this very quickly. You can always pause the video. I just expect that you know how to add and subtract. If you don't, then slow it down so that you can catch up. Okay, let's try 2, 6 and 2, 8. Well, this is kind of a special instance because when I subtract the y's and then subtract the x's wind up being 0. The x's wind up being 0. Okay, sorry about that little blip of an interruption. Somebody came to the door. So anyhow, we have 2 divided by 0, and anytime you divide by 0, what that means is it's undefined. You can't. It's a number so large you can't even calculate it. So that means that it's a vertical line. Also, if you have 0 in the numerator, like if I have 1, 6 and 4, 6, 0 in the numerator means 0. Doesn't mean no slope. It means a slope equal to 0, and that would be a horizontal line. Okay, the next one is graph a line given its equation in standard form. Okay, I like this one. So we have ax plus by equals c, and of course you know that in standard form a, b, and c have to be integers, so you're not working with fractions here, folks. So to graph a line, you need either the slope and the y-intercept or 2 points on the line. Well, we don't have 2 points on a line when we have the standard form, but we can figure out the slope and the y-intercept. Now, here's my slick trick I'm going to show you, and if you just memorize a little tiny bit of it, you'll be able to work problems really quickly like this. In order to determine the slope and the y-intercept, I need to change this to slope-intercept form, and I'm going to do it with these letters instead of plugging in numbers. So I'm going to solve for y, which means I'm going to move the ax to the other side, so I have by equals minus ax plus c, and then I'm going to divide everything by b. So now I have it in slope-intercept form, and that means that minus a over b is the slope, and c over b is the y-intercept. If you can memorize that, negative a over b is the slope, and c over b is the y-intercept, then you don't ever have to change a standard form to slope-intercept before you know what the slope and the y-intercept is. Okay, so let's go to the next page here and work a problem. So if I say I want you to graph 4x plus 5y equals 10, I know that my slope is going to be minus a over b. A is 4, b is 5, so it's going to be minus 4 over 5. And my y-intercept is going to be c over b, and c is 10 and b is 5, so that's 10 over 5, or 2. So there's my slope and my intercept. Once I know that, I can graph. I start with my intercept, which is 2, make a point there, and then I'm going to go down 4 and to the right 5, so there is my second point and there is my line, and that is just as easy as it gets. You don't have to do a whole lot of mathematics in order to be able to take a standard form and graph it. Okay? Or you can just solve for y, and in this case it's a lot more steps. So you have 4x plus 5y equals 10, or 5y equals minus 4x plus 10, or y equals minus 4/5 x plus 2, and see how many steps that took when all you had to do is know that minus a over b is the slope and c over b is the y-intercept. There you go. So here we go. Number 6 is write an equation in standard form. Now most of the time when you're going to write an equation in standard form, you have it in another form to begin with, because it's really hard to write an equation just given something and just, slap it into standard form. So generally, remember that's the form, and remember a, b, and c have to be integers. So let's say you have this that is in slope-intercept form, y equals 2/3 x plus 1/6. First thing you have to do is get rid of your fractions. There's no fractions in standard form. And my common denominator between 3 and 6 is 6, so I'm going to multiply, fractions. So we're going to clear the denominator. forgot that I had written that. So I'm going to multiply everything by 6. So I'll have 6y equals 6 times 2/3 x plus 1/6 times 6, which is 6y equals 12x over 3 plus 6 over 6, or 6y equals 4x plus 1. Now I'm going to take my 4x and I'm going to move it over to the left-hand side, so I'll have minus 4x plus 6y equals 1, and there it is in standard form. Let's try another one. This one is just kind of in, just needs to be moved around. The 3x needs to come first, followed by the y value, which would now be moved over here. It's going to be plus 7y, so I have 3x plus 7y equals 4. That's in standard form now. Number 7, write an equation in point-slope form. I love point-slope form. It's the easiest one to use. It's the one you probably weren't taught in Algebra 1, but it's what you will use in your sciences all the way through. So point-slope form is exactly that. You have a point and you have the slope. Okay, let's say the slope is negative 2/5 and the point I want is 6, negative 1. The formula is y minus y1 equals the slope m times x minus x1. If you're given m, the slope, and x1 and y1 is your points, all you do is plug and chug. Y minus minus 1 equals negative 2/5 times x minus 6. And the one thing we do want to do is change that negative 1 to a positive 1. So this is point-slope form. You don't need to manipulate it anymore. You don't need to do anything. If you're asked to change it to standard form, you can do that. But it's completely viable the way that it is, which makes it a lot easier for you. All right, let's try another one. Let's say we have negative 3, 4, and 1, negative 1. Now we have 2 points. Well, in order to do point-slope form, I need a point and I need the slope. So let's calculate the slope first of all. And we get a slope of negative 5/4. And I can choose either one of those points to plug in. So I'm going to choose 1, negative 1. So my formula is going to be y plus 1 equals minus 5/4 times x minus 1. I can use the other point also, the negative 3, 4, and with that I'm going to get y minus 4 equals minus 5/4 times x plus 3. These two don't look alike, but they are. They're the same thing, just with different points. If you would solve this and change it to slope-intercept form or change it to standard form, you'd have the same exact numbers, the same exact equations, just in a different form. Okay, write the equation of a line that is parallel or perpendicular to another line. Remember, parallel lines have the same slope. Perpendicular lines, their slopes are opposite reciprocals. Opposite meaning opposite sign, and reciprocal meaning whatever the number is, you're going to flip it upside down. All right, so for instance, if I want to go parallel to negative 5x plus 6 through the point negative 1, 4, then my slope is going to be negative 5 because it's going to be parallel to this line that I was already given. And now I want to go through the point negative 1, 4. So I'll use my point slope form. Slope negative 5, point negative 1, 4. And there you have it. Now you can change that around and you can solve it for y and make it into slope-intercept if you like. But if you're not required to do that, then leave it the way that it is. Okay, let's try another one. Let's do perpendicular. Perpendicular, y equals negative 3/4 x minus 2. And that will be through the point 1, 2. My slope is going to be the opposite reciprocal of negative 3/4. So it's going to be positive 4/3. And then through the point 1, 2, use my point slope form. Y minus 2 equals 4/3 x minus 1. So that's it, folks. Study hard, finish up your review, ask lots of questions when we do the review day, and good luck on your tests. Bye now.